Hi, welcome to our YouTube video. My name is Hong Chi Chong and I'm a student from the SKEE 3533 course Communication Principle Section 4 Group 6. In this video, my team and I are going to present about multiplexing, and here are my group members. Before delving into what multiplexing is, imagine you have three different signal sources, each carrying different data, and you want to transmit them through the same channel. How can you make sure the signal at the receiver side are not mixed? That's where multiplexing comes in. Multiplexing is a technique used to transmit multiple signals from different sources over a single communication channel without interfering with each other. Multiplexing can be divided into frequency division, wavelength division, space division, and time division multiplexing. I will be focusing on frequency division multiplexing, while my teammates will explain the rest. So, what exactly is frequency division multiplexing, or FDM? Imagine this highway as your channel, while the width of the highway is the bandwidth. Without proper lane separation, the vehicles can drive wherever they want, making the traffic less organized and less efficient. However, with proper lane separation, the traffic now becomes smoother, more organized, and more efficient. That's how FDM works. It divides the bandwidth of a channel into smaller frequency ranges, where each signal occupies a specific frequency range to prevent interference between signals. Now, let me show you some real-life applications of FDM. Today, FDM has evolved into a more advanced version called orthogonal frequency division multiplexing, or OFDM. OFDM is used in modern technologies such as 4G, 5G, and Wi-Fi networks. It allows high-speed data transmission, reduce interference, and improve the efficiency of the communication system. In short, let me conclude FDM for you in three sentences. One channel, many frequencies, with no interference. That's all from me. Thank you.
Okay, right now I will explain the wavelength division multiplexing, as known as WDM. So, what is WDM? Wavelength division multiplexing is a technique used in optic fiber communication where multiple signals are transmitted through the same optic fiber at the same time, but each signal uses a different wavelength of the light. So, why use WDM? The first one is increased bandwidth. Instead of using many fibers, WDM let you push multiple channels in one fiber. Example, 40 channels times 10 Gbps is equal to 400 Gbps on one fiber. The second one is more efficiency. No need lay more cables. This can upgrade capacity by adding wavelength. And the last but not least is scalable. You can add more wavelength when you need. So there are two types of WDM. The first one is cross WDM. Cross WDM use few channels, typically 8 until 80, and then large space between wavelength and cheaper equipment, shorter distance. And the second WDM is dense WDM. Got many channels, very narrow, long distance transmission, and used for submarine cable backbone at networks. So how WDM works? WDM contains three sides. First is transmitter side. Each data is converted to light using a different laser diode. The second is fiber optic cable. It carries all the wavelengths simultaneously. And the last is the receiver side. A multiplexer separate the wavelength. So let easy understand. Each lane is equal to one wavelength. All lanes move traffic at the same time, but no lane interference with others. WDM is a highway with many lanes inside a one fiber.
Hi everyone, I am Fu Yong Tai. Today I'm going to talk about space division multiplexing or SDM. To understand SDM, let's look at a simple analogy. Imagine a highway. If you only have one lane, cars have to drive behind each other. But if you build a multi-lane highway, cars can use different lanes at the same time without crashing. This is exactly what STM is. Instead of forcing data to wait its turn, STM uses different paths in physical space so signals don't interfere. There are two types of STM. First, we have STM using multiple cables. We simply run separate wires for separate signal. Because the wires are physically isolated, there is virtually no interference between the channels. Second, we have the modern wireless version. STM using smart antennas, often called MIMO. It allows multiple data streams to travel through the air simultaneously on the exact same frequency without interfering with each other. So why do we use SDM? First is to save cost. SDM allows us to use the same frequency multiple times simultaneously. The second benefit would be to improve signal quality. It allows us to send the same data across multiple spatially separated paths. The chances of all of them being blocked are low. Finally, I want to touch on the cutting edge of this technology, optical SDM using multi-core fiber. This is becoming critical in data centers. These facilities are interconnecting thousands of servers and they are literally running out of physical room for cables. By using multi-core fiber, we can drastically reduce the volume of cable required while multiplying the speed. In conclusion, with SDN, we can make more space. It is the way to meet the world's huge demand for data. That's it from me. Thank you.
Hi, my name is Liu Jiajun, and my teammate just now have explained how to split the frequency and use different cables. But what happens when you have millions of users, but only one physical wires? So that is where my topic comes in. Time division multiplexing, and we call it TDM. So the problem of now is if everyone tries to send the data down the same wire at the exact same millisecond, the signal will crash into each other and it will destroy. So how we can solve this? The solution is retractance. Think of a single lane bridge. We don't build a wider bridge, instead we just use a traffic light. So red car will go for 1 second and then blue car go for 1 second. So we are splitting the time but not the wire. So we do this with a device called commutator. Imagine it as a spinning switch. It touches input A for a microsecond and then grabs the signal and then spins to input B and then input C. So it does this in a thousand of times within a second. The result is a digital train called a frame. It has a reserved seat for everyone. Seat 1 is always for the red user, seat 2 is always for blue. Even if the blue has nothing to say, the seat will stay reserved, keeping it the order perfect. So this digital frame, it will take 125 microseconds to be sent. In fact, you use this every single day. Imagine when you are on a video call while downloading a file. Your computer isn't actually doing both at once. It uses TDM to switch between video and download very fast. That will cause your brain thinks it's happening instantly. But in fact, that's not. Why do we do this? The first point is efficiency. It allows internet provider to send the data for hundreds of neighbors down one strip cable, keeping your bills very low. And more importantly, it is not a radiation. TDM is just a schedule like a calendar. It has absolutely zero health impact on your body. So let's see this in action. We have two separate messages, which is the red say cats like milk, the blue say dogs had pets. So you watch at the center channel. TDM doesn't send the whole sentence at once. It drags them one by one. The first is a cat, second dogs, then lion, then pets, and so on. So it makes them up to travel safely and separates them at the other end. This is how TDM works. And finally, I want to mention here, TDM is a great technology. By using our existing wire more efficiently, we don't need to dig new mines for copper or manufacture endless plastic cables. It is a sustainable solution. So remember to call it a word, we don't always need more wires. Sometimes we just need better timing. So that's all from us. Thank you.